So I'd like to go over some things with you today concerning eclipses, why they occur, the difference between lunar eclipse and solar eclipse, and the types of solar eclipses. We're coming up to August 21st, 2017 as I record this video, and we'll go over some of the details of that, kind of focused on Nebraska because I live in Nebraska, but you can go to websites and get information for your locality, and we'll talk about some future eclipses that you may be able to view. So some of this slide source material comes from the Lunar and Planetary Institute, and hopefully you'll think this video is educational and qualifies for my use of some of their material, some of their graphics, and some of their ideas. So we have eclipses because occasionally the sun and the moon and the earth line up in a line, and we have either the solar or the lunar eclipse. It's shadows that are responsible for the eclipse, and when you're viewing, in the case of the solar eclipse, we have the shadow of the moon falling on the earth, and if you're inside that shadow area, you'll see the sun blocked out. For the case of the lunar eclipse, the moon is moving into the shadow of the earth and blocking sunlight from falling on the moon, and then we see a dimmer light for the moon. Eclipses do happen every year, both solar and lunar. They're not every month, they're more rare than that, and to see a total solar eclipse especially is rare because you have to be inside a narrow band on the earth. This band varies in width for each eclipse and varies in length for each eclipse, but let's say average 100 miles wide and could be up to 10,000 miles long across the surface of the earth. That's a long one. To see a lunar eclipse, we just have to be on the right half of the earth where the moon is above the horizon when the eclipse occurs. So many more people see lunar eclipses than see solar eclipses. To bring it a little bit on the Earth-Moon scale, we have our situation here with the Earth, and there's a little dot over here. I hope it comes through on the video. That's the moon. If you want to set up your own scale model, find a basketball, that will be the Earth, and find a tennis ball, that will be the moon, and put them roughly 24 feet away from each other. That is the Earth-Moon system. I'll give you a little picture of what's happening there. So the moon, from our point of view, is orbiting the Earth, and it turns out that the moon's orbit is not lined up with the Earth's orbit as the two planes. So there's kind of an attempt to be a three-dimensional drawing here. But this ecliptic plane, that's the plane of the Earth's orbit around the sun. If you have a tabletop, and imagine that, roll a ball around on a tabletop, that's the Earth going around the sun. That tabletop would be the ecliptic plane. And then you take a marble or some smaller object to represent the moon. And this smaller object does not orbit on the tabletop. Its orbit is tilted at about 5 degrees compared to the ecliptic plane. That means that when the moon is at full moon, over to the right here, or if the moon was at new moon, over to the left, and this is not to scale, this moon orbit is too big, and the Earth is too big compared to the sun. But in any case, this position would be full moon. Sometimes the full moon occurs when the moon is above or below the Earth's shadow that's coming out here, and we don't get an eclipse. Or for the case of new moon, the moon is below or above the ecliptic plane and does not block the sun from the Earth's point of view. So that's our situation with eclipses. We have a shadow cast by the Earth that goes out quite a long distance. A little more on that in a minute. And the shadow cast by the moon, this shadow barely reaches the Earth. So it's not as long as the Earth shadow. Why is that, do you think? Well, hopefully you realize that the reason is that the Earth is larger than the moon, and consequently its shadow goes further in space. So roughly the Earth's shadow extends a little over 1,000,000 kilometers, multiplied by 0.6 to get miles on this, so 800,000 miles. I might not have done that correctly on the fly. And then the moon's shadow goes about 375,000 kilometers. So our average distance between the moon and the Earth is 384,000 kilometers. So you can see that we have a challenge here. The moon's shadow, on average, does not reach the Earth's surface. So it's going to take us special conditions, and we'll get into that. So the total lunar eclipse, again, this is not to scale. The Earth and the moon are too big. The moon's orbit's too big. But we have the correct sense here. The Earth's casting a shadow, and as the moon goes around, it moves through the Earth's shadows, traveling here for roughly an hour through the Earth's shadow. It would be a typical lunar eclipse. That's at full moon. For the case of the total solar eclipse, or any solar eclipse, we're going to have the moon near the new moon phase. That means the moon is in between the sun and the Earth. And we can have three types of solar eclipses: an annular, where the moon's shadow does not reach to the surface; a partial eclipse, where the moon doesn't pass through the center of the sun on the sky as viewed from your location; and then a total eclipse, where the sky does get dark, like night, or twilight at least. So we call this real dark shadow of the moon shadow the umbra shadow. That's where you'll see a total solar eclipse. And only when you're in that umbra for a few minutes is it safe to look at the sun with unprotected eye. Otherwise, when we're in partial eclipse or annular eclipse, before and after a total eclipse, you must wear some protection on your eye. Typically a mylar filter in a little cardboard viewing glass is what's used. And this total eclipse only lasts a few minutes. I think 7 minutes is about the maximum for a total solar eclipse. But as I say, the moon can be, when we're at full moon, the moon can be eclipsed for an hour. And this path of totality, again, narrow, 100 miles or less would be the width of the moon shadow on the Earth. So a few calculations here. I'm not going to go over all these numbers. I'm going to give the results. If you want to pause the video and look at these numbers, you're welcome to. But we have a diameter of the sun. We have a distance from the Earth to the sun, average number for that distance. And we can calculate how much of an angle is across the sun on the sky as viewed from the Earth. This angle theta is equal to the diameter of the object divided by the distance away from us. S is the diameter, R is the distance to the object. And I do this calculation for the sun and get it into degree units. It's about half a degree, 0.533 degrees is sort of this average angular size of the sun on the sky. For the moon, diameter, distance, doing the division, the average size, angular size of the moon on the sky is 0.518 degrees. And again, you can see here, the moon being smaller than the sun, that wouldn't produce an eclipse. But the moon's orbit is not circular. The moon's orbit is elliptical. In fact, the Earth's orbit is elliptical too. That plays a little role. But the moon, when it's at the closest point to the Earth in its orbit, the perigee, then we have 0.548 degrees for the angular size of the moon, and you can see that's larger than the angular size of the sun, so we get an eclipse. And the Earth is not always the same distance from the sun. When the Earth is far from the sun, that's going to make the sun a little smaller, and that would be in our summer months for the northern hemisphere. You know, June 21st, the Earth is farthest from the sun. We won't get into seasons. Look at another video for that. But there we are. We do need some help. The moon needs to be close to the Earth in its orbit, and it does help if the Earth is far away from the sun. So partial solar eclipse, again, don't look at the sun, but here we have the sun and the disk of the moon passing through a portion of the sun, a partial solar eclipse. Do wear eye protection. An annular eclipse, if the cone of the moon's shadow does not reach down to the Earth's surface, then we'll have a bright ring of sunlight around the moon. Again, you must wear eye protection in viewing an annular eclipse. It looks like most of the sun is blocked, but there's still a tremendous amount of energy coming from this part of the sun's visible atmosphere that's not being blocked, so you must wear eye protection. And then getting into the total eclipse. So here, before the total eclipse has started, Bailey's beads is something just a short time before the total eclipse starts. Sunlight is streaming through valleys in the moon. The moon is not a perfect sphere. There are mountains and valleys, and the sunlight here is going through those valleys. So Bailey beads, and the red light over here, that's the chromosphere. The chromosphere, a narrow atmospheric region on the sun. And then just before total eclipse, the diamond ring, the last bright part of the sun, is still visible to the observer on the Earth. It's about to get covered up by the moon, called the diamond ring effect. And again, you should not be viewing that with your eye. View that with the special solar filter. Then when the moon does totally cover up the bright surface of the sun, we can see the outer atmosphere of the sun, the corona, and these streamers. This is different for every eclipse, the pattern that is here, but this is very hot gas in the very outer atmosphere of the sun. So for this 2017 eclipse in August, here's the general track from Oregon. I think Lincoln City is near there, and Salem, Oregon, pretty soon after the shadow gets into the coast. And tracking through here, through Nebraska, and down on through South Carolina, where for the continental United States the eclipse will end. It's been a long time since there's been an eclipse on the continent. I think there was one in 1979. I did not go to that, and I don't remember right now when the last total eclipse to go coast to coast was. A long time, but this will be fun. So I hope you are near the central eclipse path or can drive to it easily. Let's go a little further here. Here's from the GreatAmericanEclipse.com site. Highly recommend this. GreatAmericanEclipse.com. Here's what's happening through Nebraska, and the eclipse out here towards Wyoming, the shadow coming across, and then exiting here at the Kansas, Missouri area. And so we get about 2 minutes and 38 seconds if you're right on the track of totality. In Lincoln, I think it's about 1.5 minutes in downtown Lincoln. Omaha, it will not get totally dark, and you'll miss a great viewing opportunity. So hopefully you can be in the total eclipse path, in that shadow. So some other places that unfortunately are not going to be totally eclipsed. Chicago, again, must use eye protection viewing here. About 87% of the sun's disk will be covered by the moon. And timing, 11:53 Central Daylight Time, partial eclipse, 1:19 p.m., maximum partial eclipse. In Nebraska, it's around 1 p.m. Central Daylight Time is the eclipse when it will occur. Before that, in western Nebraska, a little after that in southeastern Nebraska. And then I think I have another one here just for the other side of the eclipse track in Dallas. 75% covered at maximum by the sun. Probably won't even notice the dimming of the light in the surroundings. And 1:09 p.m. for that maximum eclipse. Back to the total eclipse, here's some cities along the track. So Salem, Oregon, 10:17 Pacific time, and it'll be dark for 1 minute and 54 seconds. Casper, very near to the central track, 11:42 a.m. Mountain Time, and 2 minutes 26 seconds. Grand Island, Nebraska, 12:58 p.m., 2 minutes 37 seconds. St. Joe, Missouri, 1:06 p.m. Central Time, Central Daylight Time, and 2 minutes 38 seconds. Nashville, Tennessee, 2:27 p.m. It's not right on the central track, so 1 minute 54 seconds. And then my last large city here, Charleston, South Carolina, 2:46 p.m. Eastern. These are getting into Eastern time, and 1 minute 34 seconds. So if these were on the same time frame, it's about a half hour going across the United States. If I get my conversions right here, if I convert this to Eastern time, I think you have to add 3 hours. So that would be 1:17 Eastern time and 2:46, over an hour. Sorry, hour and a half to go coast to coast. Still faster than a plane can fly. I think it's going about, the moon shadow is traveling about 1,500 miles per hour across the surface of the Earth. Don't quote me on that. As far as traveling, this again is from GreatAmericanEclipse.com. You probably should look at it on your own computer screen. But they've done an estimate of how much extra population is going to be in the totality, region of totality. Some of these are just computer estimates, but some of these are interesting. Beatrice, upwards of 2 million extra people in this area. Now, personally, I think that's high, because Nebraska is not a populous state. But you should take a look at this if you're planning on traveling to the eclipse someplace. GreatAmericanEclipse.com, and click your way through to these state maps as to their estimate of what the extra crowd will be along the eclipse track. Because you may want to leave earlier than you thought you might want to leave to beat the traffic. I would highly recommend you do not park on the side of the road to view the eclipse. That's a dangerous location. There could be distracted drivers as the eclipse takes place. So find a safe parking area a couple hours before the eclipse is scheduled in your area. Would be a good plan. In the future, total lunar eclipse. And if you live in the western United States, you'll be able to see this. January 31st, 2018, early in the morning. And then this is just as the moon is about to set. And then total lunar eclipse, January 20th, 2019. That's better for everybody in the United States. It's also at a more reasonable time, 9:41 Central Time, p.m., visible all across the United States. And then a total solar eclipse, April 8th, 2024, back in the United States for a total solar eclipse. The eclipse track goes from Mexico, then Texas to Maine, and into Canada. Look at MrEclipse.com for some good information. And 1:13 p.m. near Cleveland, I might be out there. 1:13 p.m. is the eclipse time for Cleveland, Ohio. So hope you enjoyed this. Links are available at astronomy.gpclements.com. Astronomy.gpclements.com. I hope it's clear where you view the eclipse. And again, caution, be sure to use the proper eye filter, solar viewing filter, if you're viewing the sun and it's not totally eclipsed. It's only safe to view the eclipse region, the eclipse sun, for a couple minutes as the sun is totally blocked by the moon in your location. So be sure to be safe. Use approved solar viewing glasses.